Hi guys, in my previous video I've described a certain limitation of the Honeycomb Throttle Quadrant, and just to remind, the limitation is basically that in this beautiful piece of equipment, once you pass the detent line, the potentiometers of the throttle quadrant or its axis don't work as they're supposed to. For some reasons, Honeycomb decided to program them this way, so instead of given the opportunity to go all the way down and acting as axis, Honeycomb decided to assign a button to this bottom portion of the potentiometers, which may work for some people, but it's certainly a limitation for me. For planes such as King Air C90, that certainly is an issue. And since Honeycomb, I don't know when they're going to provide a solution, and whether they're going to provide one, I have no idea. And I decided that at this point I will just take care of the problem myself, and I'll try to battle the problem with the means I have. Obviously, I don't have the access to the controller board of the Honeycomb Bravo Throttle Quadrant itself, because I don't know the model of it. I don't know the firmware which they've installed. It's obviously a private firmware. So the easiest solution which I found out would be to install an additional controller and just connect this axis to another controller which I can easily program. And for that I decided to go with a little controller board, which is this small unit Arduino Leonardo. So the beauty of this particular unit and of some other units provided by Arduino and Arduino clones. So this is obviously a clone. This is not a genuine Arduino, but it does the job well, and I don't think I'll have a problem with it. One thing to keep in mind, that this particular board, Leonardo and Arduino Micro, they can actually communicate with the computer directly. They have a USB support from the computers, so they can actually be recognized by a computer such as a PC or Mac as a joystick device, or a keyboard if you want to. Some other units such as Arduino Uno or Arduino Mega don't have this capability. I know people actually try to program them, and to some extent they succeeded, but this is the easiest way to go with it. And obviously what I'll have to do, I'll have to disconnect the potentiometers from the main control board of this unit, connect them to the Arduino Leonardo, and just program it so this board is detected as a joystick with 6 axes, which will be detected by explaining level. So let's see what I can do, and I'll go along with the videos, and hopefully it's going to work in the end. Now, before I go any further, I would like to mention a few things. First of all, this particular job will require some soldering skills. So if you have never done any soldering, perhaps this particular work is not going to be for you. But at the same time, soldering will not be required for the high-end electronic components. It's mostly wire soldering, so maybe it's okay if you practice it with a simple soldering gun. Also, you may need to require a few additional tools. Obviously, you'll need the wire cutters to cut the wires from the unit. I purchased this set of wire jumpers, which will make my job much easier once I start connecting the board. Another thing which I would like to mention is, obviously, and it is obvious for me, but for some of you who think that this job will be an easy job to do and it's not going to cost you anything, one thing it's going to cost you is your warranty, obviously, because if Honeycomb will see that this unit was taken apart and some wires were cut, obviously you'll lose your warranty. I think that should be mentioned as well. We'll start by removing the screws which hold the bottom plate of the throttle quadrant, and with this I will be able to access the internal components. So there are 13 screws here. They're not covered by any seals or anything, so they're pretty readily accessible. All I need is just a screwdriver, and once I remove the screw, it should open pretty easily. And here's our unit. So what we need to do right now, I will disconnect this wire cable, connecting two parts. And this is the USB port right here. So I will have to disconnect this one, and then what I will do, I will cut these small wires going into every of these 6 potentiometers here. I will cut it in half and find a way to splice it and solder in between, so I can actually add my Arduino board inside. And I will also run a cable, so I may need to make a hole through it, so I can run a USB cable. So now all the wires are cut, and all is left to do is to solder together the ones which go to the ground and to the positive 3.3 volts, and those are white and red wires, and the black wires will be the signal wire which will go to each of the Arduino channels on the analog input pinouts. So I finally finished soldering of all the wires, and I've used a piece of this plastic strap to connect all the wires together. So there are 6 signal wires which are colored, and the 2 wires, the ground and positive wire, which will go to 3.3 volts of Arduino. So I have the signal wires will be 2 throttle wires, 2 props, and 2 mixture wires. And the way to connect them to Arduino will depend on your code, obviously. In my code, I assigned all 6 analog inputs between A0 and A5 as inputs for all signal wires. So A0 and 1 will be throttle, A2, A3 will be props, and A4, A5 will be mixture control. And I have 3.3 volts here, and ground wire will go here as well. So let's connect everything together and see how it works. So this is the board finally connected to all the signal wires, as well as ground and positive wire. I actually decided to use plus 5 volts. That most likely gives me a better resolution than 3.3 volts. I'm not really limited to 3.3 volts since I'm completely disconnected from the original board. So 5 volts will be used, and let's plug it in and see how it works. So everything is plugged in. As you can see, the board is connected. I plugged it into one of the USB ports on my computer. I've also connected the Bravo Throttle Quadrant to its port. And now I'm going to test if everything works as it should, or we have any issues. So let's start checking our joystick devices. And let's look at, so Arduino Throttle Quadrant, that's what I call my Arduino joystick, which is this board here. And let's look at the properties. So I do have 6 axes, and let's see how it works. So this is my throttle quadrant, and you can see, like, you can hear the click. It goes below the detent line right now, and it goes all the way from 0 to the maximum position. And then I have my second throttle, also the detent works. Prop 1, again detent. Prop 2, mixture control 1, and mixture control 2. So everything seems to work. I also assigned 3 different buttons. I didn't connect them to Arduino yet. I may actually assign more buttons as in case if I want to add any additional switches or any other options to any of the airplanes in the simulator. So I have that option. It's going to be pretty easy to add, and I have 3 of them. Just for the moment they're not connected, but it doesn't matter if they're here. So now let's check the Bravo Throttle Quadrant, and what I'm going to check is if all the functionality works except for the axes themselves. So I'm going to test every single button. So this is my gear, works fine. This is my flaps, button 15 works fine. The trim wheel 22 and 23 works fine. Autopilot 1, 2, 3, 4, 5, 6, 7 buttons. Then the mode selector, button 17, 18, 19, 20, and 21. And again, this is a knob. The rotary control works fine. The switches in the front, they don't seem to show anything, which is kind of surprising. But what I found, that they actually work perfectly in the simulator. So I don't know why Windows is not capable of detecting those switches. They work perfectly fine, and I'm just going to demonstrate it in a second. So all in all, it looks good. There's some imbalance in the axis, which is understandable because the board doesn't see the potentiometers installed, so it doesn't know where the actual resistance of the axis is. So I don't really care about it. Okay, let's run the simulator. In my case, it's Explain 11, and see how it works in the simulator. So once in the simulator, I see that I have my Arduino Throttle Quadrant recognized by the simulator software, and I see 6 axes here and 3 buttons, which again are disconnected. I may need to think about something if I have these buttons already. But in any case, let's test the axes here in the simulator. And so my throttle, for some reason, it's on axis 4 and 3, which is okay. Axis 2 will be my, and axis 1 will be my props. Sorry, axis 1 will be my mixture control, actually mixture control 1. Axis 0 is the mixture control 2. Prop on axis 2, another prop on axis 3, axis 4, and axis 1. So axis 5 are my throttle. So everything works fine. And let's look at the Bravo Throttle Quadrant. So as I mentioned, the buttons at the front didn't show up in Windows for some reasons, but when I click them in the simulator, they recognize no problem. And every other button, so let's say my autopilot, heading, nav, approach, reverse, altitude, course, and indicated airspeed work fine. And mode selector recognized fine. The rotary knob works perfect. Flaps recognized. Gear up, gear down, and trim wheel up and down. Works fine. So all in all, everything works. All I need to do is just to close this unit, and I will be ready to fly. Now, before I go to the actual simulator to test how the system works, I would like to mention a couple of things. First of all, I actually did a couple of changes to the Arduino Throttle Quadrant, and I've added 6 additional buttons to this axis. The way how they were done by the Honeycomb, if you remember, as soon as you pass the detent line, the axis would register the button click. Now, what I've done, I have done kind of the same thing, and the reason for that was, let's say I'm in King ARC 90, and I go from the alpha mode to reverse, and then to the maximum reverse, and I want to be able to register that I'm actually in the maximum reverse mode in X-Plane, and for that reason I can assign a button right at the bottom of it. I don't need to use it if I don't have to, but if it's there, it's nice. And as you can see, so I just opened my joystick control for the Arduino, and you see that I've added 6 additional buttons. So there were 3 in the beginning, and now there are 9 of them. And if I go past the detent line and I reach the bottom, you see button 4 lights up, and same for button 5, button 6, 7, 8, and 9. So all of them registers button. It's just a simple modification of the code, and this is the beauty of Arduino, because I have no idea how Honeycomb programmed their controller, but in this particular case, Arduino is an open source software. It's an open source board. Everybody can reprogram it to the way they like it, and we can do anything we want. Now, another thing which I'd like to mention is the code I'm using is originally is not my code. I actually borrowed it, and I used a video which explains how to program the Arduino joystick control in Arduino library. There's a nice video explaining it. I just want to give credit to that person who created this video. It's called Arduino Joystick 2.0 Library Beginner's Guide, and I put a video in the description so you can actually download an example code from that video, so you can also use it in your flight simulator if you ever need it. And it's pretty straightforward, but I just wanted to mention this guy because without this particular video it would be difficult for me to actually create my own code. And I will definitely put my code in the description of this video so you can use it, you can see how it works. It's pretty simple, pretty straightforward. In case if you need to add any buttons or you need to add any access, it's still possible. And here it is. So let's go into the simulator and see how it works. Now everything has been put together. I've closed the quadrant. I glued the Arduino board with the thermal glue so it doesn't move around. So now everything looks neat and tidy. And again, all the functionality of the buttons has been preserved. And the only change which I've done was I was using the Arduino to control the axis of this throttle quadrant. And that's going to be particularly important in one particular model of the airplane, which is King ARC 90, where if we go past the detemp line, we can go into the reverse mode for the engines, and we can feather the engines, and we can fully utilize the mixture control. So to demonstrate, I just loaded my King ARC 90 in my X-Plane 11, and as you can see, if I start moving my throttles up, it acts as normal. But what happens if I move them down, it actually goes past the detent line into the beta mode, and then finally into the full reverse mode. If I wanted to see how it affects the plane, you can actually see that in the reverse mode my plane starts moving backwards, which you normally are not supposed to do. Let me bring my throttle back to the neutral position at the detent line. And, if I move my props all the way down, I can go into the feather mode. And again, right now I'm at the detent line for the mixture control. I can move it up to the high idle or low idle, or I can cut off the engines if I wanted to. The final word is how everything is set up in Explain 11. So again, this is my controller board, which is Arduino Throttle Quadrant. That's how I called my Arduino board here. You can call it whatever you want. It doesn't matter, honestly. So I have 6 axes here. Now, let's look at one of the throttles. You would have to check mark this option has beta reverse detents, which splits the whole curve into 3 different regimes. One is normal regime, which is normal throttle here, and the beta and reverse mode. And that's what you do for both throttles to control your left and right engines. And for props, again, this is where I set my feather point. And one suggestion is to have this point a little bit below the detent line so you don't accidentally hit it, because there's a little bit of flexibility, there's just a little bit of wiggling how this how the levers can go. And finally, again, for both props, I use this option, set feather point. And finally, for the mixture control, I set this mixture cutoff point, and I used it a little bit, actually quite a bit below the detent line, so I have quite I have enough room to move my levers before the engines will be completely cut off. And obviously it's quite flexible, you can change it. One other thing is, just to reiterate, again, I added the buttons which would be engaged if I hit the bottom of any axis I move. In this particular case is here, if I move both my throttles, then button 3 and button 4 get engaged, and I assign them to hold thrust reverse max if you want, which is quite useful. You don't have to use those buttons, but it's quite useful to have them. And they're all programmed inside the code. The code will be, I put a link to the code below the video description, or in video description. So this is it, guys. It was quite a bit of a project for me, and I apologize. It took me quite a while to post this video. It took me a while to finish everything, put everything together, and in the end it works fine. And the only option which I may be missing is the ability to program this this axis from inside the Bravo Throttle Quadrant program, which is an additional program you can download for Windows or for Linux. I don't plan to program them inside the that program, so that's not an issue for me. But all those buttons can still be programmed inside. This is it. I hope it was quite educational for you guys, and if you have any questions, put your comments below and I'll try to answer them to the best of my ability. And stay safe and healthy, and take care.